My name is Philopatir Meshreky, and I work as an area sales manager for DIOSNA since the beginning of this year. Before that, I used to work as their agent in Egypt for the past 8 years. So I'll start off with a little brief about DIOSNA. So DIOSNA was founded in 1885. We're approximately 320 employees. We have approximately 80 million euros in sales. 70% of everything we produce is exported. Our main industries are pharma, flavor, and bakery. So we're located in Osnabrück in Germany. And we're the inventors of the high shear mixer. So we've invented the high shear mixer in 1965. As you can see, pharma was a little bit different. You could apparently go with the slippers to the factory before that. So we're specialists in mixing, granulation, and drying. So our business model is helping you with the know-how and the process. So we have a big lab in DIOSNA with a process division, and we're aiming to always help you from the R&D to the scale-ups of the machine. So quickly, what is wet granulation and why is wet granulation important? Because it gives you content uniformity, you control the stability, API release profiles, flowability of the product, and so on. So in the agenda, we will be talking about different wet granulation techniques, and we'll have a short comparison between different techniques. Each technique, I think, has benefits, and it's always according to your product, and it's a criteria to help you in choosing what type of wet granulation would be helpful for your process. So first off, we start with the mixer and dryer. So it's a typically manual process, and it takes a very long process time. So this was the start of the drying in the pharma industry. But the problem is you can dry your product for more than 10 hours, which is quite typical. It's a very manual process. You have a very high risk of spillage because you're moving everything into the trays and you're putting the trays into the dryer. The good thing is about it, it has a very low investment cost if you compare it to other techniques. And also it produces high to medium dense products according to the high shear mixer produced. And second off, which is the normal granulation line, which I think you see everywhere. It's a typical granulation line where you have a high shear mixer, a wet mill, a fluid bed dryer, and a dry mill. So you do the mixing in the high shear mixer, you add your binder liquid, it's wet milled, it goes to the fluid bed dryer and then into the dry mill. You can have it as a fully automated process where everything's automated, everything's in a closed system. The problem is it has a high investment cost. It will produce you high density particles, and it has good containment, which was not possible with the tray drying technique. A third technique is the single pop process. So it's also a fully automated process. It's a medium investment cost, and it's excellent for containment because you have everything in one pot. So you have all your risk in one place. You clean only one place, and you have a very good process. It's a little bit similar to the other process where you do the mixer and you add your binder liquid to granulate. Then you start with the drying by heating out the double jacket with the motion and the air coming inside. Then you have a good process. It's a medium investment because you don't have a fluid bed dryer. You only have everything in one pot, and it produces high density particles. I think its only problem is the high content of fine being produced from this application. And the fourth part, is the fluid bed granulation, where you have your granulation and the mixing and everything to be done in the fluid bed dryer. It's a fully automated process. It's a medium investment cost. It's a good containment because also everything is in one pot, but it's not as good as the single pot because you have everything going through the product filter afterwards. It produces low density particle and it has a narrow particle size distribution. And another problem that it requires specific raw material properties in order to run it in the fluid bed dryer. If you have very sticky products, then fluid bed dryer granulation is not for you. So you have two types of granulation that can be done in the fluid bed dryer. You can start with the typical top spray granulation, universally applicable. A lot of formulations are being produced that way, so it's quite traditional to the pharma industry. What is new and gaining traction is the tangential spray. So instead of spraying everything on top of the product, you're actually spraying with the direction of the product. So the product moves in a tangential motion inside of the fluid bed dryer, and you're spraying in the direction of the product, and the product is moving inside, so you can have a higher spray rate. So you have a shorter process time. You will have a denser product, so it's more efficient. The problem is it requires an extensive revalidation. So transfer from top spray to tangential spray isn't quite easy. You will change most of the parameters. You will change the spray rate. You will change the air speed inside. So it's an extensive revalidation process. So you'll typically change everything inside of it to have it working. So here we're comparing the granulation between the high shear mixer granulation, top spray and tangential spray, starting off from the same materials with the same density. You can see that you have a narrower particle size distribution coming from the fluid bed granulation in comparison to the high shear granulation, but you have a much denser product coming out of the typical high shear granulation than the top spray or tangential spray, but the tangential spray has a higher density than the fluid bed dryer. In regards to the process time, so they're a bit similar. So you have shorter granulation in the high shear mixer, but you have more time drying because the particles motion inside of the fluid bed dryer, they're starting to dry already. So you have a shorter drying time in comparison to the top spray and also to the tangential spray, but the drying time is lower than the high shear mixer. Okay. Here we're comparing the productivity of the 4 different techniques for the mixer and tray dryer, high shear granulation, single pot, the fluid bed dryer, using the same materials. So the longest process time is in the mixer and the tray dryer because of the time that needs the tray dryer for drying. Some of my customers take more than 12 hours in the tray drying. If you compare it to a high shear granulation with a fluid bed dryer, it's less than 2 hours. If you compare it to a single pot, it's a little bit over 4 hours. And for the fluid bed granulation, it's 3 hours. For the cleaning time, you will take substantially long cleaning times to clean the tray dryers. With the high shear granulation, you have also a long time because you're cleaning a lot of components. You're cleaning the high shear mixer, the fluid bed dryers, and the mills with it. Takes quite a long time. And the single pot has the least cleaning time because you're cleaning everything in a pot, and also which brings us back to containment. So cleaning and containment usually takes a long time, so it's always good in containment to look for single pot because it takes much less time. And for the fluid bed granulation is a little bit more than the single pot. For the preparation time, the least is the single pot. It's just charging the material. For the material handling for the high shear mixer, single pot or fluid bed granulation, it takes roughly the same time in comparison to the tray dryer, which takes more time to place everything on the trays. We also did a comparison. We're comparing whether if you're producing everything in batches or in campaigns. So the most efficient in producing campaigns is the high shear mixer fluid bed dryer and the single pot. afterwards is the fluid bed dryer, and the mixer and the tray dryer is the longest time. If you're running a campaign, the most efficient system is always the high shear mixer and the fluid bed dryer, because it has the shorter process time in comparison to the single pot and the fluid bed granulation. Also, tray dryer is always the biggest process time. So also it's to be seen in the graph. Second is the cost of investment absolute. The highest cost of investment is for the high shear mixer and the fluid bed dryer, then for the single pot, then for the fluid bed dryer, and then least is the tray, the mixer, the tray drying. But if you compare the investment cost per batch, including what you put in it, the productivity, then you save more money by working with a more efficient product and producing more using the same facilities in the factory, using the same resources, and so on. For the cost of operation, only including productivity and only energy consumption, so the most efficient is the high shear mixer and the fluid bed dryer. If it compares, then you will see that the fluid bed dryer goes afterwards, and then the single pot, because the single pot is a little bit energy extensive. The drying takes more time than the fluid bed dryer, because the particle motion in the fluid bed dryer is a little bit more aggressive from the movement of the product and with the air inside. And then one of the least efficient as well is the tray drying. If we add with it the depreciation because of the investment cost that's been paid with the high shear mixer and the fluid bed dryer, then the highest is the high shear mixer and the fluid bed dryer, because it has the highest absolute investment, and then the fluid bed dryer, the single pot, and then the fluid bed dryer, and then the tray drying. And if you add with it the productivity, then the other processes where the high shear mixer and the fluid bed dryer is the second most efficient in comparison to fluid bed dryer or top spray processes, to the single pot, and the worst would be the tray drying. Then it's a comparison. So to have a better yield, you're always checking for the lowest contact surface, because product on the side is usually where your main loss is in the big line. So if you're comparing, then the biggest product contacting surfaces is for the closed system high shear granulation, and then you have the fluid bed dryer, which has quite a big surface. Then with the tray, and also because you can easily scrap the product out of the tray. And the last one would be for the single pot process. You only have a very high risk of spillage in tray dryers, but for the other process there is no risk of spillage, because everything is efficient, everything can be automated, and everything can be closed. So if you look at the average product loss, for example, the single pot is the least, a very small area, everything in one pot. And if you compare it to the high shear mixer and the fluid bed dryer, which you have a little bit of higher loss, you have losses in the piping sometimes in between if you're not scrapping it, to the surface of the high shear mixer, the surface of the fluid bed dryer. And for the tray dryer, it's 1 to 3%, so yield is not very bad, but you still have a very high risk of spillage coming through it. And for the fluid bed dryer, you only have one surface, which is the fluid bed dryer, so only it's 1 to 2%. So for a higher yield, the single pot has the highest yield. So this is why also some people look at it in containment, because you have high yield, you have everything in one pot, easily cleanable, and it's according to how you produce. Will you be producing usually in campaigns? Do you have high changeover between different products? It's always according to what the marketing wants to produce. In regards to the fine content, you have a very low fine content coming out of the tray dryer. If you compare it with the high shear mixer and the fluid bed dryer, it's low to medium. You have a high content of fines coming out of the single pot because of the motion of the impeller while it's drying, and also a very high content of fines coming out of the fluid bed dryer because of the motion of the particles inside of the fluid bed dryer. So you're granulating and everything's moving, you're breaking up granules, and then you have fine. For the particle shape, it's irregular in the tray drying in comparison to the round shape you get from the high shear mixer and the single pot. And in the top spray, it's also irregular. So you have, for the particle size distribution, the narrowest would be for the fluid bed dryer, and you have a medium distribution coming out of the high shear mixer and the fluid bed dryer, and the medium to wide distribution coming from the single pot, and the wide particle distribution coming out of your tray dryer. For the containment, it's impossible to have it in a tray dryer, of course. You have a high cost of containment on the high shear mixer and the fluid bed dryer due to the big area, and the lowest cost to the single pot. And for the fluid bed dryer, it's considered medium cost. For the climate and weather influence, so everything's influenced by the weather, to the efficiency of the drying, to heating the air and removing the humidity, except for the single pot, because the single pot uses air coming inside of the room. For the solvent recovery, it's a high cost for all the systems except for the single pot, because a typical single pot systems always comes with its solvent recovery system. For the explosion protection, the most expensive is the high shear mixer and the fluid bed dryer, because you'll be paying for a lot of components to be explosion proof, to be shock proof, for example, in comparison to the tray mixer. In comparison to the fluid bed dryer, where only one component or two components need to be explosion proof. And finally, we go to the space requirements. So we're comparing different systems where they need space to be utilized in the facility. So we have the GMP area, the technical area, and the total area. So the smallest in the GMP area is the single pot. Then you have the fluid bed dryer, then the high shear mixer fluid bed dryer combination, and lastly the tray. But for the high shear mixer and the fluid bed dryer, you need a substantial area for the technical. You need a big technical area because of the high shear mixer cabinets, and for the air handling units of the fluid bed dryer. And then you have the fluid bed dryer, because the air handling units take substantial space, and also with the blower. And then you have the single pot, where you only have the solvent recovery kit afterwards, and the least area is for the tray dryer in total. This is a picture showing an area for a single pot system. So you only have the single pot, the cabinets, and this is the only utility, which is the solvent recovery system for the process air which is coming outside of the single pot. If you compare it to a granulation line, then you have a substantially bigger area where you have the cabinets, you have the air handling units, the WIP skid, and you have a much bigger area inside to fit in the high shear mixer fluid bed dryer with the wet mill integrated and the dry mill.